AWS Academy, and predominantly support the educator in the West Coast of the US Central, and Canada. And if you're here today, it's either I invited you directly or you sign up through the event calendar from the AWS Academy forums. Thank you all for joining. The topic for the webinar today is Amazon VPC. We want to see how we can use Amazon VPC to curate a networking environment within the AWS cloud. And not only that, we will look at the various connectivity services or features that you can use together with Amazon VPC to set up a secured and available networking environment. And in order to achieve that, we have these following sections. But before we proceed, if you are leaving early, we've started recording the session, and everybody will have access to the PowerPoint deck that we will use today. I will send to everyone at the end of the session, and also the demonstration document, such as the CloudFormation template that I've created for the demo. You will all have access to it. Therefore, if you are leaving early, you don't have to worry. And if you join late as well, or you don't have to worry, you get access to all the webinar documents. Yeah, thank you. Thank you. And also, please, as usual, please don't forget to provide feedback on the webinar by filling out the post-event survey. Post-event survey is already added as a link to this deck at the end. Also, when you end this webinar session, you will be redirected to the post-event survey page. Please take 2 minutes of your time to provide feedback. Ayobami, you raised your hand. I might need to share the screen for me to enable you to talk. If you would not mind, can you put your comments or question in the chat? If you have comment or question, please put it in the chat. I have the chat in front of me and I can quickly use that to respond. Yeah. Thank you. These are the sections that we have today. And if you have any question, before we start, after the content of the webinar, before we start the demonstration, we have about 3 to 5 minutes to ask our question. Please, if you have any question as we move along, please note it down so that when it is time for question and answer, you'll be able to ask your question. We want to do this in order to be able to flow through the content as fast as possible in order not to delay us here. The sections today we'll first of all understand or talk about extensively the concept of AWS or Amazon Virtual Private Cloud, also known as Amazon VPC. We'll talk about what is it used for, what are the available features that we can use with it, and what are the connectivity options available to us with Amazon VPC and so on. And also we'll discuss how you can secure your internetworking environment using Amazon VPC. We'll talk about the various features of the network security layer. That is how you can secure your network environment using layered security. And we'll also highlight some troubleshooting steps that you can apply when you are troubleshooting your network on AWS or with Amazon VPC. And finally, we will do a demonstration, and this demonstration is about setting up Amazon VPC and various components of Amazon VPC, such as subnets, such as curating a route table, such as curating the internet gateway, and configuring the route table and setting up an EC2 instance within a public subnet so that we can access the application in that public subnet. And this demo will, if we have to go through each of the console to set up this, it will take a longer time than expected. Therefore, I've created a CloudFormation template that we can just deploy to curate all these resources. And when it is time for demonstration, I will seed the template and go through some of the resources in the template before we use it to deploy our networking environment and various Amazon VPC components. At the end of today's webinar, we'll expect that we will be able to explain Amazon VPC as a cloud networking or AWS networking service. Also, we'll be able to identify the various networking components of Amazon VPC and their functions. We'll also be able to understand the various, some of the connectivity services available with Amazon VPC. We'll be able to identify how you can, what are the methods available to secure your networking environment using Amazon VPC. We'll also be able to see the steps that we can follow to troubleshoot any VPC network related issues. And finally, we will go through a demo where we will use Amazon or AWS CloudFormation to automate Amazon VPC and the networking component. These are the things we'll be able to cover, and I hope we'll be able to stay as long as possible to go through the content with me. Amazon VPC is an isolated portion of the AWS cloud, or a VPC. Let me start with VPC first of all. And VPC stands for Virtual Private Cloud. It's an isolated portion of the AWS cloud that you use to provision and deploy AWS infrastructure services. It is a virtual network, and as such, it supports multiple subnets, routing, and fine-grained security, because we talked about layer security earlier mechanisms. And a VPC, that is a virtual private cloud, is created in AWS cloud using Amazon VPC service. You see, we have a virtual private cloud, which is an environment, and to create such a virtual private cloud within AWS, you use a service called Amazon VPC. And VPC, like I said earlier, stands for Virtual Private Cloud. When you configure a VPC using Amazon VPC, you define its IP address range, subnets, and route tables. As you can see, these are terms and concepts that we're familiar with our basic or normal computer networking. You can also optionally use the internet gateways or hardware VPN solution to securely connect to it or to on-premises corporate network from your Amazon VPC. And this is where I mentioned we'll look at various connectivity options. Because if you are operating or you are managing a kind of hybrid cloud environment, that is, you have some networking resources or some IT resources within the AWS cloud, and you also maintain some resources within an on-premise data center, and you want all these resources to be able to communicate. How do you do that? AWS has various connectivity services that you can use to connect these two cloud environments together. And that is what we mean by hardware VP solutions, or connectivity solution or options that you can use to connect to your Amazon VPC. As you will have expected with networking environments, IP addressing or IP address configuration is very important. And when you create a VPC, you must specify its allowable IP address range. This is what we call the CIDR block, right? That is classless inter-domain routing, CIDR block. This range represents either IP version 4 addresses, and it is expressed using the CIDR block. As you can see on this slide, that's what we mean by /16 or /28. This is CIDR block of IP. And these ranges, that is /16 or /28, for example, are known as the primary CIDR block. After creating your VPC, you can optionally add up to 4 secondary CIDR blocks to a VPC. And you can only define your VPC with CIDR block of 16 and 28 inclusive. That means that your VPC can contain from 16 IP addresses, which is /28, to 65,536 IP addresses, and that is /16. What this means is that you cannot create a VPC below /28. That is, you cannot create a VPC with /30 IP address or /29 IP address. That's what we're saying. And you cannot create a VPC with IP address more than /16. That means you cannot create a VPC with /15 IP address, for example. Meaning the maximum you can create is a /16, which gives you about 65,536 IP addresses. And the minimum you can create is a /28, which gives you about 16 IP addresses. And also, as a best practice, AWS recommend that you should restrict your the range of your IP addresses to the one specified in the standard document request for comment, that is RFC 1918, which defines the address range that can be used by a private network. We are not talking about IP addressing today, because IP addressing, as you will all agree with me, is a very important concept in computer networking. But those knowledge of IP addressing that we have is the same knowledge we need to configure IP addressing for our Amazon VPC. And for more information about the RFC 1918 document, please let's check the internet to see more details. If I've not gone through it before, if we don't remember most of the details of this request for comment document, please let's check it on the internet. But this is just to show us that you can use IP address with your Amazon VPC, and you can only create maximum of either 16 IP address block or minimum of /28 IP address block. And this screen depicts or represents the CLI command that would generate the VPC that is shown in the console. That means just like every other AWS services, you can access, you can use or communicate with Amazon VPC, either using the AWS Management Console or using the AWS CLI or using the AWS SDK that is within your programming environment. And this CLI command that you can see here represents that you are creating a CIDR block for your VPC, and the CIDR block you are creating is 10.0.0.0/16. That command will return some JSON-like document that will show you your CIDR block, show you some other information. And this same command, you can do the same thing using your management console like you saw on the graphics on this slide. And just like your normal computer networking, some IP addresses within an IP address CIDR block are reserved for special purposes. For Amazon VPC, the first 4 IP addresses and the last IP address in each subnet of a CIDR block are not available for use and cannot be assigned to any resources or to any AWS EC2 instance. For example, in a subnet with a CIDR block of 10.0.0.0/24, the table you see on this slide depicts the 5 IP addresses that are reserved. As you can see, the first, just like our basic networking or normal IP address networking, the first IP address in a CIDR block is always reserved for network address. And this is the same thing with Amazon VPC. In Amazon VPC, the second IP address, and in this case 10.0.0.1, is reserved by AWS for VPC router address. We're going to understand or see the router address later in the session. And the third IP address in a CIDR block is used by AWS for DNS service. And this IP address is reserved, for DNS purposes. And it's always the third IP address in a CIDR block for your VPC. As you can see in this example, 10.0.0.2 will be reserved for DNS server of your VPC. And the fourth IP address, which is in this case 10.0.0.3, is reserved by AWS for future use. And the last IP address in this block, which is 10.0.0.255, is reserved for network broadcast address. Just like in our normal IP address networking, where we reserve the first and last IP address in a block for network and broadcast address respectively. That's the same thing here, just that these Amazon VPC reserve 3 additional IP addresses in conjunction with those two for different purposes, and therefore they cannot be used or be assigned to our instances within an Amazon VPC. We need to understand these details of these reserved IP addresses if you are preparing for AWS Certified Solution Architect Associate exam, or you are preparing your student for the exams. They won't ask the question directly like this, but your knowledge of how these IP addresses are reserved for different purposes is important for you to answer some questions correctly. And here we want to look at the various features of Amazon VPC. This diagram illustrates the main characteristics of features of a VPC. The first thing we want to look at here is an Amazon VPC or VPC can span multiple availability zones in an AWS region. That is, for example, if you create, if your AWS account is region is changed to US East 1, for example, that's the Northern Virginia region, your Amazon VPC in your account in that case can span all the 6 availability zones in that region. That's what we mean by VPC can span multiple availability. It does not have to, depending on your use case, but it has that capacity if you need to span all the availability zones in the region. That's the first thing. The second thing is that VPCs have an implicit router that route all traffic in the VPC. And on this graphics, you can see a router icon between the availability zone A and the availability zone B. And remember earlier we said the second IP address in a CIDR block is reserved for this router. Also, in this graphics, you can see VPC have default route table, and this default route table specify the allowed route out of a VPC or out of the VPC. And by default, this table defines a route. We know when we're talking about route in a route table, we're talking about rules, right? And this rule or this route allows all traffic in this example for the CIDR block IP address range to be routed locally. You can see if you have /16 of this kind of IP address for your VPC, your default route table will have a route for this table so that all the IP addresses or all the resources within your VPC can be routed locally within the VPC using the rule or the route in the route table. And therefore, the default route table has a rule to route all traffic that is designed for that range through the local routes. And in our next slide, or in the next slide, we will examine how subnets and route table are used in a VPC. What we're trying to explain here are the various features of Amazon VPC. Availability zones, a router, the route table. But how do you use all these components together in a VPC? We'll talk about it in this slide. Subnets are used we know what we do Amazon VP, or what we use Amazon VPC for, is to be able to create our own networking environment within the AWS cloud. However, you can also use the subnet, which is a component of your Amazon VPC, to further segment your VPC IP address range to provide logical groupings for resources. For example, you can create a separate subnet for resources of different types, such as your EC2 instances, your database instances, or in fact, you can even create your resources within your VPC with different visibility. Either you can make them public or private. For example, because you know your customers need to publicly access the application running on your Amazon EC2 instances, you can deploy your EC2 instances within a public subnet. Or even if you are using an Elastic Load Balancer, you can put the EC2 instances, let's say, behind a private subnet, and you put your Elastic Load Balancer in a public subnet. Because you know in that situation, all the connection will come through the Elastic Load Balancer. And also, you can put your RDS or your database services or resources within a private subnet, because you do not want public access to those resources. This is what we mean by different visibility. Another example is to use subnet to divide resources by team or department. That is, if you are working in a big organization, right? We want each department to have their own subnet. You can use subnet to achieve that. You can put accounting department in their own subnet. You can put the IT department in their own subnet. You can put the HR department in their own subnet. This is one other way by which you can use the Amazon VPC subnet to segment or to divide the resources of your organization into teams and departments. You can create up to 200 subnets per VPC, meaning in a single VPC you create within your account, you can create up to 200 different subnets in that VPC. And for IP version 4, the minimum size of a subnet, which I mentioned earlier, is a /28 CIDR block, which is a 16 IP addresses. And for IP version 6, in this case, the subnet size is fixed to a /64, and only one IP version 6 CIDR block can be allocated to a subnet. We have to understand that when we are dealing with IP version 4, how is the configuration managed in Amazon VPC? And when we are dealing with IP version 6, how is the configuration managed with Amazon VPC? This is what we're trying to explain here. And, we're trying to explain how you can use Amazon VPC subnet to manage the visibility of your resources, or to divide your teams and the department within an organization into different grouping using the Amazon VPC subnet. And remember that when you put your resources within a subnet, you are one way or the other trying to create a kind of security for them. For example, if you put your database services or RDS instances within a private subnet, what you're trying to do indirectly is you do not want public connections or internet connection to those devices. Thereby, you are protecting unauthorized access to those devices. We need to remember that, because later we'll talk about layered security for Amazon VPC, and that will be the first layer. For more information about Amazon VPC subnet, please let's check VPC from the AWS documentation. Now, this diagram here illustrates some other characteristics of a subnet. First of all, we must understand that subnets can only exist in one and only one availability zone. That is, if you create a subnet, which will be a subnet of your VPC IP address, it can only exist in one availability zone. For example, on this slide, if you have a subnet like you have in availability zone A, 10.0.10.0/24, you cannot have this CIDR block in availability zone B as well. That's what that means. Subnets can only exist in one and only one availability zone. And in a subnet, the IP address range of its CIDR block must be a subset of its VPC address range. As you can see in this example, the CIDR block for the subnet in availability zone A allows for IP addresses from 10.0.10.0 to 10.0.10.255. And the CIDR block in availability zone B supports IP addresses from 10.0.20.0 to 10.0.20.255. As you can see, both of these subnets are subset of the VPC IP address range, which is between 10.0.0.0 to 10.0.255.255. Yeah, we need to understand that if you even if you want to have another subnet within this availability zone now, you can call it 10.0.30.0/24, and you will still see that .30.0/24 will still be a subset of 10.0.0.0/16. It's very important for us to understand that. And we need to understand that subnet CIDR blocks within a VPC must not overlap. This is true in the diagram that you can see here. You can see that 10.0.10.0/24 does not overlap with 10.0.20.0/24. They do not overlap. There is not any overlapping point between those two IP address CIDR blocks. You need to understand that as well. Also, you need to know that traffic to and from each subnet flows through the implicit router or the VPC. You see? Meaning that if resources within this subnet need to communicate with the resources in this subnet, how would that happen is to use the router, the implicit router here. And remember, the first IP address in this range will have been assigned to that router for the purpose of this communication. For the purpose of this communication. It's important for us to understand that. And these are the other more information we want to talk about the Amazon VPC subnet. Now, the next thing we need to understand is the auto-assign public IP address feature of Amazon VPC. That is, if you create or you launch EC2 instances in a default Amazon VPC, you receive a public IP address during the creation. You need to understand that. That is, if you don't create, if you want to use Amazon EC2 instances without creating your own VPC, the kind of VPC you are using at that time is called the default VPC. And the EC2 instances that you create into your default VPC gets public IP address or IP addresses automatically. However, if you create your own VPC, that's what we call custom VPC here, and you want to launch EC2 instances into that VPC, you will need to override the default settings to be able to receive public IP addresses. What this means in a nutshell is that if you are using your own customized VPC, that is the VPC that you curate to launch EC2 instances, they do not get public IP addresses by default. You will need to override the custom setting, or you enable the getting a public IP address automatically for those kind of instances to get public IP addresses. And that's what we refer to as modify auto assign IP settings on subnets to automatically assign public IP addresses to those instances. And another thing we need to understand is that unlike elastic IP addresses, public IP addresses are not static. What this means is that your public IP addresses will be released from an instance, that is an EC2 instance or an RDS instance, when the instance is stopped or terminated. However, if you have an elastic IP address, which is also a public IP address, they are static and they are reachable from the internet. You see, we have two types of public IP addresses. The one that you get automatically for launching EC2 instances or other instances into your default VPC. And you have the one that we call elastic IP address. And these elastic IP addresses, you have to first of all curate them. And after you curate them, you can then attach them to an instance. And if you don't need those instances anymore, you want to terminate those instances, you can detach them, those elastic IP addresses, and reattach them to other instances that will be curated later. And they do not change. Even if you stop such an instance, when they come back up, when you restart them, they still maintain the same elastic IP addresses. And that's what we mean by they are static, whereas the public IP addresses are not static. Now, we want to look at another component of Amazon VPC called the route tables. Each VPC, as you saw in one of our previous slides, comes with an implicit router that directs traffic between resources in each subnet and out of the subnet. And this router uses a route table to determine the valid IP destination out of a subnet and the corresponding target that is used to reach the destination. And a route table, as you know, in computer networking, is a mechanism that we use for routing traffic that originates from an associated subnet in a VPC. And it contains a set of rules. And you know, a set of rules, as you can see in this route table, are called routes that determine where traffic is sent. And route in a route table consists of a destination and a target. And as you can see in this route table, if you want to read one of those routes, you will read it as any traffic that goes to destination, right, should be routed via target. And your target that you specify could be a specific instance ID, right? It could be an elastic network interface ID, an internet gateway, as you can see in this custom route table, or even a virtual private gateway. Even you can specify as well, the virtual private gateway of a particular subnet, depending on what kind of devices you have. But as you can see here, your target could be the ID of the internet gateway, as you can see in this custom route table, route 2. Also, when a VPC is created, I mentioned that earlier, a default route table is also created with a rule that routes local traffic anywhere within the IP address range of the VPC. And you can add more route to the default route table when you create a subnet, and it's automatically associated with the default VPC of that. And if you don't want to use this route table, that is, if you don't want to use the default route table, you can create your own custom route table, as you see in this graphic, and associate it with the subnet instead. Meaning, if you don't want to create additional route table, you can edit a default route table and add more routes that are required for necessary routing within your Amazon VPC. However, if you also like, you can discard the default route table, create your own custom route table, and add all the necessary routes required for the necessary networking you have set up within your Amazon VPC. And each VPC might also have an internet gateway attached to it. An internet gateway is a device or is a service. We usually refer to it as a service because, you know, the whole concept of Amazon VPC is virtual. And when you use the word device, most times we want to look at a particular tangible component. But in this case, we prefer to use the word service. Therefore, Amazon or internet gateway in Amazon VPC is a service that routes traffic to the internet. When an internet gateway is attached to a VPC, route tables that belong to the public subnet might use it to forward traffic to the internet. And as you can see in this diagram, we have two subnets. Subnet 2 rather is associated with the default route table. And the single route in this route table is defined in the stable state that traffic is allowed out of the subnet only to the IP addresses in the VPC IP address range. As you can see, 10.0.0.0/16, and the target is local. That is, the traffic going through any of these IP addresses in this range should be routed locally within the VPC. However, subnet 1 that has a custom route table is associated with a custom route table that has two routes. The first route is the same as the one in the default route, which means that local traffic is allowed out of the subnet to the IP addresses in the VPC IP address range. In addition to this one, we have a second route, which is 0.0.0.0/0, states that traffic to any other IP addresses are also allowed and should be routed through the internet gateway, which is defined by the internet gateway ID as the target here. You see, meaning any IP addresses coming into this subnet can be routed to the internet using the internet gateway. And remember, as you can see here, internet gateway is always created into the public subnet. Even if you want to use a NAT gateway also will also be created in the public subnet, and then you can link or configure the resources in your private subnet to that NAT gateway. We'll talk about NAT gateway in a moment. This is how you can use your route table to manage routing or internetworking within your Amazon VPC using the subnet. It's important that we understand this. It's just, you know, the concepts are similar to our basic networking. For those that have worked with Cisco routers or other form of router before, and we have configured or we have updated route tables in those routers before, the concept of route table configuration in Amazon VPC will be very, very easy to understand. Now, the next thing we want to look into here is what we call elastic network interfaces. Is it possible to change the network segment in the VPC after deployment? Ronnie, what do you mean by changing it after deployment? Does that mean, are you referring to saying that attaching those resources? Yeah, you can use a different network. Yeah, that's possible. Just that you have to ensure that the different network you are using has the necessary route configuration within the route table for the resources to know which route to pass, either internally or externally. Yeah. I don't know if that answers your question, Ronnie. Yeah. Thank you. Yeah. And each network interface, as you can see in these graphics, has a primary elastic network interface that cannot be detached from it. You see, when you have an EC2 instance, each EC2 instance that you create has a virtual network interface, which we refer to as network interface card in basic or on-premises networking attached to an EC2 instance. And this primary instance or elastic network interface cannot be detached from it. However, you can add additional network interface to an EC2 instance. And as you can see in this example, additional network interfaces here are the network interface 2 and the network interface 3. You might be dealing with use cases that require you to have additional network interface being attached to an instance, as you can see here. And one of those use cases will be maybe when you are using network and security appliances in a VPC. There might be some configuration or security configuration for your Amazon VPC that require that you use network or security appliances within a VPC. And in situations like that, you might need to have additional interfaces for your network load balancer or for your network address translation NAT server or proxy server in order to be able to configure them with multiple instances or multiple, elastic interfaces or network interfaces. Another use case for that can require you to have multiple network interfaces for your EC2 instance is when you are connecting an instance to a service provider by AWS private link. We'll talk about that later as well. Because there might be some situation, maybe security requirement within your cloud resources that require that the connections between your resources should not go through the internet. Therefore, you can use the AWS private link to set up what we call interface endpoints, such that this interface endpoint will allow you to communicate, for example, between EC2 instance and your S3 bucket privately without going through the internet. And in this kind of use case, you will need additional network interfaces, so that you can create this interface endpoint for it to create, so that you can create the elastic network interface and attach it to the invoking instance. Yeah, you need to have additional network interfaces for you to use the private link that will create the interface endpoint to allow this private connection between your network resources. And for more information about private link or interface endpoint, we'll still mention another type of endpoint later called the gateway endpoint. You can check the elastic network interface from the AWS documentation. These are some of the components. We can't go through all the components of Amazon VPC within this webinar because Amazon VPC is a very huge service. And if you go to the interface alone or the management console of Amazon VPC, you will see tons of services or resources that you can use together with Amazon VPC, and you need to understand them properly for you to use them. And if you want to know more about any one of them, you can just search them from the AWS documentation online. Now, I have mentioned briefly the Amazon VPC, DevOps VPC. Yeah, we want to possibly talk more about this because it is important that we understand. We use this DevOps VPC all the time, but we might not know how it gets there or how you can use it or how it's being used to manage your internet working activities. When you create an AWS account, you set up an account with AWS. AWS automatically create a DevOps VPC for you with a CIDR block of /16. But this kind of IP address that you see will be 172.31.0.0/16. And like I've said before, any /16 IP address, whether it's a class A, class B, or class C, definitely provide you with 65,536. But because this block of IP in this case is a private IP, the kind of IP addresses that you get will be 65,536 private IP version 4 addresses between 172.31.0.0 to 172.31.255.255. And this default VPC enable you to start using VPC features immediately. You need to understand it because it's there for you, and without even you understanding properly the concept of Amazon VPC, you can use the default VPC to manage communication between your AWS resources. And AWS also automatically creates additional components for your default VPC. And what are the additional components? One of them is the internet gateway that I mentioned earlier. And the internet gateway allows communication with the internet. Another additional component created with your default VPC is a default route table, which has rules to send traffic to IP addresses in the VPC address range to a local route and traffic to any other IP addresses to the internet. You can see the default route table of your default VPC usually have these two routes. One that allow communication locally using the IP address range of your VPC, and one that allow communication with the internet, which configure a route of any IP addresses, setting the ID of your internet gateway as the target. Also, apart from these two components we have mentioned, internet gateway and default route table, with your default VPC, you have a public subnet in each availability zones with a /20 CIDR block size of IP addresses, which provides 4,936 addresses for each of the subnets. And this subnet as well have the auto-assign public IP option enabled so that any instance launched within the default VPC could automatically get a public IP address. And they are public subnet because that's what differentiates a public subnet from a private subnet. They are public subnet because they are associated with the default route table, which has a rule that allows traffic through an internet gateway. That's what differentiates. If you say you create a public subnet within a subnet of Amazon VPC, that subnet is just a subnet until you configure a route in your route table that routes certain IP addresses or all IP addresses to the internet, setting your internet gateways or one of your internet gateway as the ID. If you don't do that, your subnet is just your subnet. But after configuring that route in your route table, then a subnet can become a public subnet. These are the 4 different additional components, or let me say 3 different additional components that comes with your default VPC. An internet gateway, a default route table that has routes to route your traffic locally within the VPC, and another route that routes the IP addresses to the public internet. That's the second component. The third component is you have a public subnet in each of the availability zone with a /30 IP addresses, and that's a public subnet has auto-assign public IP address option enabled by default, and this public subnet too is added to your default route table so that any traffic that want to communicate with the internet within your VPC can get to the internet. We have been able to possibly look at the various components of Amazon VPC that we need to set up Amazon VPC for our Amazon cloud network resources. Here we want to look at the various connectivity options and methods that are used to connect a VPC to external entity, including the internet, external clients and endpoints, and other AWS services. That's what we want to look at now. Now, this table here provides options for connecting an Amazon VPC to other VPC and even other AWS services. And this table also lists the common VPC connectivity scenario and identify the recommended AWS service or networking component to use to implement the corresponding solutions. For example, the first scenario we'll see here is if you need to connect a private subnet to the internet. You see, we've talked about internet gateway in the previous slide and how you can configure the instances or resources in your public subnets to be able to route them to the internet. But what if you have a private subnet and the resources in the private subnet need to connect to the internet? For example, if you have EC2 instances in a private subnet, and that EC2 instance or those EC2 instances need to fetch or download security patches to the operating system from the internet. How would they do that? Because they are not in public subnet. You need a NAT gateway. A NAT gateway, NAT stands for Network Address Translation. Like we do NATing in our Cisco router. That's what the NAT gateway does. It allows the resources within a private subnet to be able to get access to the internet, but there will not be a connection from the internet to those instances. Remember, NAT gateway is always deployed into the public subnet because it must have an elastic IP address to be able to route all the collections of private IP addresses within a private subnet to the internet. That's the first scenario. If you want to connect private subnets for resources in the private subnet to connect to the internet, you can use the NAT gateway. NAT gateway is one of the AWS or Amazon VPC service that you can use. The second scenario here is if you want to connect a VPC to another VPC. You remember that you can have more than one VPC within your AWS account. Let's assume you have a VPC and the resources in that VPC, you want them to be able to communicate or share connections or data with another VPC. And these two VPCs can be in the same account, in the same region. The two VPC can be in different regions. And even in fact, these two VPC can be in two different AWS accounts. You can use another Amazon VPC component called VPC peering to make this connection possible. VPC peering. Another scenario here is if you want to connect a VPC in your Amazon VPC to an external network, you can consider any of the three of the following services. One of them is AWS site-to-site VPN. AWS site-to-site VPN, as the name implies for those that are familiar with how VPN works, the VPN will still go through the internet, but it creates a kind of security tunnel such that the communication between your VPC and the external network is secured and protected. It's secured and protected because of that security tunnel. It's like a pipe within the internet so that to shield the communication from unauthorized access or from the man-in-the-middle attack, it provides that tunnel. That's one of the services that you can use to connect your Amazon VPC to an external network such as your on-premises data center. Another device you could consider to connect your VPC to external network is what we call AWS Direct Connect. AWS Direct Connect is an Amazon VPC service that you can use to create a private dedicated connection between your VPC and the external network. You can see AWS site-to-site VPN gives you the public secure tunnel. But if you do not need the communication between your VPC and external network to go through the public internet at all, you can deploy the AWS Direct Connect to manage the connection. And this service gives you the private communication you need and even dedicated. Another device that you can use to manage communication or connection between your VPC and external device or network is what we call the AWS VPN Cloud Hub. The AWS VPN Cloud Hub can be used with or without a VPC. And you can use this device or this method if you have multiple branch offices that have existing internet connection and you want to implement a convenient, potentially low-cost hub and spoke model for primary or backup connectivity between these branch offices. You can use the Amazon VPN Cloud Hub. Even if you don't have a VPC in place, you can still use this service. These are some of the services that you can use to connect your VPC to external network. Depending on your use case, would determine which of these services that you will use. And the fourth scenario that we have here is if you need to connect a VPC to other AWS services without leaving the AWS network. What does this mean? If you need to connect your VPC, let's say to Amazon S3 or to Lambda function, for example, without going through the internet first, you can use any of these services. The first one is the AWS Private Link. AWS Private Link provides private connectivity between your VPCs, supported AWS devices, because it's not all the AWS services that support AWS Private Link, and your own on-premises network without exposing your network to the public internet. That is, you can use this private link, like I explained earlier, to create what we call interface endpoint between two AWS services, for example, between an EC2 instance and Amazon S3, such that the communication between those two services will be private without going through the internet at all. You use the private link to set up this interface endpoint. And as the name implies, the communication is private, it's not public. Another device or service that you can use to manage this kind of communication is what we call the Gateway VPC endpoint. The Gateway VPC endpoints provide reliable connectivity to other AWS services, such as Amazon S3 and DynamoDB, without requiring an internet gateway or a NAT device for your VPC. Because if you need an internet gateway or NAT device or component for your VPC, that means your connection will have to go to the internet first. But if you use Gateway VPC endpoint, you can manage the connection privately within the AWS network without going through the internet. But you need to know that when you use Gateway endpoints, you do not use the private link that I mentioned earlier, and you have to pay additional fee for using the Gateway endpoint. But if you use the interface endpoints powered by AWS Private Link, you do not have to pay additional fee for that. These are the two ways by which you can connect your VPC privately within the AWS network without going through the public internet. And the last scenario that we have here is if you need to connect a VPC to multiple VPCs and external networks. Remember, we mentioned VPC peering earlier. You can only use VPC peering to connect two VPCs together. But if you need to connect multiple VPCs together, and in fact, to connect them with external networks, you can use another service called or component called AWS Transit Gateway. And the AWS Transit Gateway simplify your network and put an end to complex peering relationships. Because VPC peering and AWS Transit Gateway, learners mix those two together. If you want more information about these two connectivity options, you can search the AWS documentation for more information. Also, If you are preparing for the AWS Certified Solution Architect Associate exam, or you are preparing your student for that certification, they need to understand the differences and the use cases for VPC compared to the use cases for AWS Transit Gateway, because these two services require that you connect VPC together. But you have to understand that VPC peering is not transitive. Transitive meaning, let's say you connect VPC A to VPC B, and VPC B is also connected to VPC C using VPC peering. This does not implicitly mean that VPC A is connected to VPC C. No, it does not mean that. If you need that connection, you have to set up another VPC peering, explicitly, because the VPC peering is not transitive. That's what we mean by that. Because of those confusion and differences, you need to understand the differences between these two, because you might, your student might see, or you might see some questions relating to them on the exams. The next thing we want to talk about, I mentioned that previously in this last slide we just looked at, in the scenario, we talked about the network address translation, that's NAT. Let's look at these graphics here to paint the scenario that require you to use a NAT gateway. Let's say you consider a situation where you have an instance with a standalone database that runs in a private subnet, and you want to apply a software patch, like I mentioned earlier, to this database, but the private subnet prevents you from accessing the internet to download the patch. Because remember, the RDS instance is deployed within a private subnet. You cannot put the instance in a public subnet because you do not want internet client to connect to it. However, you need a way to connect from this instance to the internet without getting or receiving internet connection or client to this particular instance. How do you do this? AWS provides two solutions for you to do this. The first one is the NAT gateway, and the second one is you can use what we call the NAT instance. A NAT device could help you to forward the traffic from the instance that is in private subnet to the internet or other AWS services and send the response back to the instance. Yeah. You can use a NAT device, either a NAT gateway or NAT instance. A NAT gateway is recommended in this case because it provides better availability and bandwidth compared to NAT instance. And also, the NAT gateway service is also a managed service from the AWS that does not require manual administration. NAT instance, on the other hand, is not a managed service. You have to create an EC2 instance and set it up manually yourself to be able to act as a NAT device. And that is why AWS recommend that you use a NAT gateway. You don't have to deal with the manual administration or management of the device, and because it's a managed service. And also, it provides better availability and bandwidth compared to a NAT instance. For more information about how to set up a NAT instant device for the resources in your private subnet, please let's check NAT instance from the AWS documentation. And also, we can also, if you want to know more about the NAT gateway as well, we can check NAT gateway from the AWS documentation for more information as well. And this slide here explain how, or the steps and the steps of setting up a NAT gateway and the characteristics of NAT gateway. Like I mentioned earlier, a NAT gateway is a managed service, and it can be created in a specific availability zone, and it is implemented with redundancy in that availability zone. And like I mentioned previously, earlier, that it requires an elastic IP address. Remember, because if you are using a NAT gateway, that means you want to route a collection of private IP addresses to the internet. Therefore, you need an elastic IP address. An elastic IP address is the public IP address that does not change. Remember, that's static. And the NAT gateway support different protocols such as the Transmission Control Protocol, TCP, the User Datagram Protocol, UDP, and even your ICMP, that is Internet Control Message Protocol used by your pings. NAT gateway support that. Meaning, if you set up a NAT gateway, you can ping your instances connect to that NAT gateway using the pings to determine whether they are up or down if you set up the protocol. And to create a NAT gateway, you have to specify the subnet where you want to create it and select the allocation ID of an elastic IP address to associate it with. That's the first step. The second step will be that you update the route table for the private subnet to point internet traffic to it. This enables instances in those subnets to communicate with the internet. And for more information on how this whole thing or setup works, you can check the NAT gateway configuration from the AWS documentation. The diagram here illustrates the architecture of an Amazon VPC with a NAT gateway. And as you can see below the screen here, you can see the main route table, how it sends traffic, internet traffic from the instances in the private subnet to the NAT gateway. See? Because this route 0.0.0.0/0, which is the destination, specify the NAT gateway ID as the target. What that means is that the traffic from those instances in the private subnet send traffic to the internet gateway. And the NAT gateway then send the traffic to the internet gateway by using the NAT gateway elastic IP address as the source IP address. You can see that is how the instances in the private subnet can get access to the internet using the NAT gateway with this proper configuration that you can see here. And as a best practice, AWS recommend that if you use multiple availability zone, host a NAT gateway in each availability zone for better availability. That is, if you have, let's say, 3 availability zones, and you have private subnet with resources in each of those availability zones that need access to the internet, you have to deploy 3 different NAT gateways to manage those resources for better availability. That's the best practice by AWS. Now, we mentioned VPC peering previously. We want to use this diagram here to explain how the VPC peering connection works. By design, VPC are isolated network section, as you have seen in the AWS. And if you need to connect VPC together to exchange traffic or data, like I mentioned earlier, you can create a VPC peering. And a VPC peering connection is a networking connection between 2 VPC that enable you to route traffic between them by using private IP addresses. The VPC can be in the same region, as I've explained earlier. They can be in different regions or even in different AWS accounts. The data that is exchanged traverses privately on the AWS backbone. That is, they only go through the AWS data center, and no gateways are required for peering to work. Remember, because you are using the private IP addresses, the connection will be private. The connection will never leave the AWS network. And the connection is controlled by route table, which are referencing which reference the peering connection as a target for routes. As you can see in these two peering here, you can see VPC 1 in account 1 and the VPC in the second account. And you can see the route table of the private route table of the VPC in account 1. One of the rules or one of the routes there specify VPC rule for the one in the second account. The same thing in account 2 also specify a route pointing to the private IP address in account 1. These configurations of the routing table is required for the VPC peering to work. If you configure one part, you do not configure the other. Therefore, one part can work, the other part might not work or will not work. Let me put it that way. Therefore, you need to ensure that not only that you specify that you want to configure VPC peering between two VPCs, you need to add the necessary rules or routes to the routing table for the peering to work. And that's what you can see on this slide. The next thing we want to look at is the VPC network security. And for VPC network security, like I mentioned when we start the webinar, AWS recommend what we call to provide security at several or different levels. And providing security at several or different levels is what we refer to as layered network defense for VPCs. As you can see, we have 4 levels here. The first one is, using the VPC route tables that we have been discussing so far. And this particular one is the most broad scope level of security because it's at the route table level. As you have learned earlier, having a private subnet with no direct path to the internet is one of the best ways to protect your internal computing resources against unauthorized access. We know that because there could not be a client from the internet having access to those resources because they're already protected behind a private subnet. That's why we refer to it as the most broad scope level of security, which is level 1. The second level is the network access control list, also known as network ACLs. Network ACLs provide the ability to define the default security behavior for your subnet. Remember, network ACL works at the subnet level, and they are used to protect your resources at the subnet level. For more information about network ACL, please search for network ACLs in the AWS or from the AWS documentation. The security group is the third layer of security and can be used to control the behavior at the instance or elastic network interface level. Remember, you use the network ACL to manage security at the subnet level, and you then use the network security groups to manage security at the instance level. And you have to understand that network ACL is stateless. It's stateless. That is, if you allow the communication into your subnet, you have to explicitly allow that communication out of your subnet. That's why it's stateless. But security group, immediately you allow the communication into your instance, you do not need to specify or explicitly specify the outbound rule for that communication or connection, because security group is stateful. The in is required, the out is automatic. You have to understand that. And the fourth layer or security layer or security level that we want to talk about here is you might choose to use some form of third party or host-based detection software or device that monitor individual Amazon EC2 instances for specific threats within your network. And these threats could include malware intrusion, also known as operating system vulnerability, and in fact, even for the purpose of security auditing, you can use this kind of third-party devices. If we want to know more about each of these layers of security, we can check them. We've talked extensively about route table today, but you can check the network ACL from AWS documentation. You can check security group from AWS documentation. In fact, you can check the differences between these two levels of security to see the differences and the similarities. These are the four security levels called the layer network defense for your Amazon VPCs. And here, before we start the demonstration, we want to look at the various troubleshooting steps that you can apply when troubleshooting connectivity issues with your Amazon VPCs. The common troubleshooting tasks include when troubleshooting issues that are related to your connectivity is exhausted. That is, you want to provide a good starting point for most problem determination efforts. The first thing you need to do is you have to verify that the instance that you are connecting to is up and running. And how will you know that instance is up and running? You can check that from your EC2 management console and ensure that the service is saying running and the status check is saying checks 2/2. That is, the system status and the instance status are passed. Another thing you need to check is to verify that the security group associated with your instances allow the connection that you're trying to access, either through the port or through the protocol. For example, let's say you want to browse, you are browsing an application running on an EC2 instance and you are getting connection error. The first thing you need to check is, okay, is that EC2 instance running? If you're sure that it is running and you can see it, you want to check the security group attached to that instance if it allows connection on port 80. If it does not allow connection on port 80, that might be why you're unable to connect. You need to go to that security group and add an inbound rules that allow connection on port 80, which is HTTP. Then if you try again, you will see that you should be able to connect to the application. The next thing you need to do if you have connectivity issues and the first and the second steps are not the issue, you have to verify that your network ACL, if you have one that is associated to your subnet, allow the connection from the necessary ports and protocols. You remember that we mentioned layered security for your Amazon VPC earlier. Yeah, you use ACL at the subnet level and you use security group at the instance level. If you specify a network ACL for your subnet and you're having connectivity issues, you might want to check that you have specified the correct rules, or your inbound and outbound rules for the ACL. And finally, let's say you want to browse an application running on an EC2 instance, and you notice you could not connect using the IP address, for example. You've checked that the EC2 instance is running. You've checked that the security group allows connection on the necessary ports and protocol. And you did not deploy, for example, a network ACL for your subnet. The next thing you need to verify is that the necessary rules or route is configured in your routing table, specifying your internet gateway ID as appropriate. Because if you say you set up a public instance or a public subnet without configuring a route for your internet gateway in your table, then you have not set up an internet connection to your EC2 instances. You need to verify that they specify the necessary route within your route table for the connection that you're trying to achieve. These are the common troubleshooting tasks you might experience. And this one, let's say if you cannot connect to the instance via the internet, I think I've just explained something like that. The first thing you need to do is that you have to verify that the instance is running. Also verify that the security group allow connection over the ports or protocol you are attempting to connect to. For example, for SSH connection, that is secure share connection, you have to verify that port 22 is open, and the web server connection, for web server connection, that is for HTTP and HTTPS, you want to verify that the port 80 and port 443 are both open. That's the first thing. The second thing is you want to verify whether the public IP address has changed. Remember earlier that we said if you are using just public IP address or public IP addresses, if your EC2 instance is stopped, it will not, when you start it later, it will receive a new public IP address. You want to verify that the necessary configuration of your IP address or public IP address is working, and also verify that the internet gateway and route table settings are correct. This is very important. If you could not connect to an instance via the internet, these are the things you need to check. And let's say if you cannot connect to an instance using SSH, you need to verify that the connection credentials. Remember, because anytime, even though you have set up you have opened port 22 for your EC2 instance, you still need that you specify the username and password correctly. That might be the case. I don't know whether you have experienced that before. I've experienced that before. I want to connect to my EC2 instance using the SSH, either POTI, because I'm a Windows user, and I want to connect to a Linux EC2 instance. I have gotten the IP address. I have specified the key, the necessary key. But when I need to specify the username, instead of me to specify the EC2 user, unless you change it, I use an admin username, and I was getting error. I was now reading, what's the problem? And I remember that, oh, I didn't change the default username, and the default username for Amazon EC2 is always EC2 user. And that was where the problem is. Immediately I specified the EC2 user on my Linux terminal, I was able to SSH into my EC2 instance successfully. Therefore, you need to ensure that you have the username correctly and the instance private key is specified correctly. That's the PPK if you are using Windows. And also, if the NAT configuration does not work, let's say you have some instances behind a private subnet, and those instances need access to the internet. Just notice that they could not connect to the internet. You have to verify that the route table has a route to the NAT gateway or the NAT instance. And if you are using a NAT instance, which AWS does not recommend, you have to make additional checks as specified on this slide. And the next thing is, if you cannot reach resources in a peer network, that is, you have set up peer VPC peering between two VPC within your AWS account, but you find out that the connection is not working. The first thing you need to ensure is that if the peering request sent from one VPC to another is approved. And you have to also check that the security group allows the necessary configurations. You have to also check the network ACL associated with each of those VPC, allow the connection you are trying to establish. Even though it's VPC peering, the security groups and the network ACL still play important roles because they must, you must have associated a network ACL to your subnet, or you must have associated security groups to your instances you're trying to connect to. And if those rules do not allow the kind of connection you're trying to make from one VPC to another, even though the peering is in place and is approved, the connection will not be successful. Will not be successful. Therefore, you need to check all this. These are some of the examples of how to troubleshoot. We showed how you can troubleshoot connections for your EC2 instances, whether it's SSH. We have explained how you can, the troubleshooting steps you can follow to troubleshoot NAT gateway connections. We have also gone through the steps of what you need to check if you are having difficulty connecting to resources in a peered network that you set up using VPC peering. These are just some examples. There are various types of issues you might have within your VPC, but following all these troubleshooting steps will possibly help you a lot to see how you can resolve those connection problems. And remember that troubleshooting is part of our job as a teacher or as a technology or computer science person. Yeah, it's very important. Now, these are all the things we need to look at today. And if you have any questions, please let's ask the question now. We can put the question in the chat. I want us to ask all the questions we have before we go to the demonstration part to look at what we want to demo, and then go to the AWS Academy LMS, which is Canvas, to set up. Okay, in slide 19, what do the IP address this refer to? 198. Slide 19, we have to go back to slide 19. 198. Yeah, these are possibly the different IP addresses within your availability zones A. Because you might have different public IP addresses here. These are just examples that if you do not use /10 IP, you can use /1. If you do not use 10 dots range of IP, you might be using 198 straight of IPs. These are just examples of different types of IP you can use. I don't know if that answers your questions. These are just alternative to 10.0.0.5, 10.0.0.6, or 10.0.0.7. Alternative 198.51.100.1. If that is the IP address that you specify for your VPC, if it is a 198 block. Is it tied to any? Is it tied in any to the NAT gateway? To the NAT gateway, as you can see, the NAT gateway, will possibly have an elastic IP address of /4. The example of this IP here, thank you. I think I see what you're saying now. These are just example of NAT gate elastic IP addresses that you possibly you have curated within your account, and you are using one of those elastic IP addresses for your NAT gateway. Thank you for that clarification. Those are NAT gateway, what's it called? Example of elastic IP addresses. Maybe you curated 4 of them, and as you can see, these are public IP addresses in I think class C public IP addresses. And one of them, you are assigning it to your NAT gateway. These are additional elastic IP addresses possibly you have curated. But this is not recommended in AWS. If you will not use an elastic IP address, don't create it, because you are going to be charged for any elastic IP addresses that you create that you do not use. But if you use the elastic IP address, you won't be charged for it. Although AWS is changing the rule starting from next year, for you to be paying for even the public IP addresses that you use, organizations. Leanne, I don't know if that answers your question. That's an example. Those are examples of elastic IP addresses. And one of them that you curate within your account should be associated to the NAT gateway. And remember that we mentioned earlier that one of the steps that you will follow to set up a NAT gateway is to assign an elastic IP address to it, so that all the instances in your private subnet can use that elastic IP address to communicate to the internet, perhaps to fetch the security patches they need. Yeah. Thank you for that clarifying question. That helps me to understand better what you were asking. Thank you. Okay, if we have any further question, please let's ask. Thank you.